Hi everyone, hope you all are good. So, we're working on quadratic relations. You can find a lesson in the book Grade 10 Principles of Mathematics, Grade 10, and the chapter we're working on is chapter 4. The lessons we're going to start with is 4.5 quadratic relations of the form y equals ax minus r, x minus n, and 4.5 is negative and 0 exponent. So, let's just start with 4.4. Okay, here it is. We are already working on 4.5, that is, we are going to start with question number 11 because in the last class we did question number 11. So now we're going to start with question number 11, right? Okay, 11 is factor x square minus 16xy plus 64y square. So let's just start with question number 11. Okay, hold on. Okay, question number 11 is okay, just 1 minute. Okay, let's just start with question 11. X square minus 16xy plus 64y square. Let's just start with question number 11. A. Let me just write it down on board. Question number 11. A. Okay, the question is 16 x square minus 16xy, x square minus 16xy plus 64y square, right? So we have to factor the given equation, right? So how do we factor? Let's just see. Here you have, this is the square of x, that is x square, and this is the square of 8y, this is 8 square, minus you have 2x and y is 8y. Basically, this is the equation in the form a square minus 2ab and plus b square. So when you have equation in this form, you can rewrite it as a minus b whole square. So this is a and this is b, so it would be x minus 8y whole square, right? The correct option is x minus 8y whole square. Okay, the next one is, let's just do 36x square minus 25y square. 36x square minus 25y square. So you have to factorize, right? Okay. So this one 36x square, this is the square of 6x, and 25y square, this is the square of 5y, right? So it would be 6x minus 5y. Whenever you have something in the form, hold on. A square minus b square, you can write them as a minus b and a plus b. So you can see this is the square of 6x and minus 5y square. So you can rewrite it as a is 6x minus 5y and 6x plus 5y, right? So the correct answer is 6x minus 5y and 6x plus 5y, right? Okay, let's just do the last one. 50x square minus 8xy square. Okay, 50x square, 50x cube minus 8xy square. Okay, 50x cube minus 8xy square. Okay, let's just take common 2 and x. So we're going to take common 2x, and we are left with 2 times 25x square minus 2 times 4. X is already outside, you are left with y square. So you can factor, you can see 25x is the factor of 5x, a square of 5x, and 4y square is the square of 2y, right? So you can write it as 5x minus 2y and 5x plus 2y, right? Okay, let's just start with the next question. Okay, question number 12. Factor each expressions, explain the strategy you used. Okay, a is x square minus c square minus 8x plus 16. Let me just write it down on board. X square minus c square minus 8x plus 16. Okay, okay, you can see x square minus 8x and plus 16, right? You can factor them as a perfect square. X square minus 8x and plus 16. It could be factor out as a perfect square, right? And minus c square. This is you can consider as a, and this one you can consider as b, right? This would be x square plus 4 square minus 2 times 4x, right? So it would be x minus 4 whole square, and this is the square of c. You can treat this complete as a and this one as b, right? So you can write it as a square minus b square. So you can write it as a minus b and a plus b, right? This way you can factor. You just have to rewrite this. You can see x square minus 8x plus 16 is the perfect square of x minus 4 whole square, right? So just rewrite them and make a perfect square of x minus 4 whole square minus c square. Consider this complete thing. This one is a minus b and a plus b, right? Okay, the b part is 4c square minus a square 4c square minus a square minus 6ab minus 9b square. Okay, this one is a perfect square, right? You can just take common negative outside, you're left with a square plus 6ab and plus 9b square. This could be then perfect square of a square plus 2 times 3ab and plus 3b square. You can see this one is the perfect square of 2c. Just rearrange them, right? And this one is a plus 3b whole square. Just consider it a and this complete as b, so it would be a minus b and a plus b. Here you have negative then, right? You just have to make them, you just have to rearrange them. Like we know that a square minus 6ab minus 9b square is the perfect square, right? So you just make them together and make them the square of a plus 3b whole square, right? Okay, the next one is question number 13. Examine each quadratic relation below. Express the relation in factored form, determine the zero, determine the coordinates of the vertex and sketch the graph of the relation. So let's just start with A. Y equals negative x squared plus 16x minus 64. Question number 13. Okay, the equation is y equals negative x squared plus 16x minus 64. Okay, minus 64. Okay, and what values you have to calculate? Relation, express the relation in factor form, determine the zeros, determine the coordinates of the vertex, and then sketch the graph. Okay, let's just. Okay, first of all, we have to factor. Just take a negative sign common. You are left with x square minus 16x and plus 64, right? This is a perfect square for x square. This is the square of 8 minus 2 times x times 8, right? So that means this is the perfect square of x minus 8 whole square, right? You have to calculate the zeros, right? So that means when y equals 0, it would be 0 equals negative x minus 8 whole square. That means x minus 8 equals 0, so x equals 8. This is the 0. That means the 0 is 8, right? Then you have to calculate the vertex. So when x equals 8, when x equals 8, the equation is y equals minus 8 minus 8 whole square. 8 minus 8 is 0, y equals 0. That means the vertex is 8 and 0, and for the last part you just have to graph the equation, right? Okay. Okay, let's just look at question number 16. Multiply a plus b, a square minus ab plus b square. Compare your product from part A with the factors of the original expression. Identify the pattern you see. Okay, let's just multiply them. Question number 16. A plus b, a square minus ab and plus b square, right? Just multiply them. A times a square is a cube, a times negative ab is minus a square b, a times b square is ab square. Same thing you have to do with b. B times a is a square b, b times negative ab is negative ab square, and b times it is b cube. I think rest of the things will be cancelled out. You are left with negative a square b and positive a square b cancel. AB square and negative AB square. So you are left with A cube plus B cube, right? Okay. Use the pattern you identify in part B to factor. Okay, x square plus 8. You have to factor x square plus 8. Just see. This is the cube of x and 8 is the cube of 2, right? You have to rewrite them like this. It would be a plus b, x plus 2, a square minus ab, 2 times x is 2x, and b square, that would be 4, right? Let's just do another one. 27x cube plus 8. Okay, 27x cube is the cube of 3x and 8 is the cube of 2. So just rewrite it would be 3x plus 2, and you have 3x square, 9x square minus 2 times 3 is 6x and plus 4, right? Okay, you can complete the lesson by, look, let's just do, you have to do the same thing with question number 17, right? Okay, you can complete the lesson by yourself later today. Let me just move on to next lesson. We're going to start with the lesson 4.6, that is reasoning about factoring polynomials. I think I reasoning about factoring polynomials. Hold on. Let me just add it the lesson name. Okay. Let's just start with 4.6, that is reasoning about factoring polynomials. Okay. Okay. The strategy you use to factor an algebraic expression depends on the number of terms and types of expressions in the expression. You can use the following checklist to decide how to factor an algebraic expression. Divide out all the common monomials factors. If the expression has two terms, check for a difference of squares, right? This is the strategy you have to follow when you are factoring the algebraic expressions, right? Okay, if the expressions have three terms, check for a perfect square. If the expressions have three terms and is of form ax squared plus bx plus c, look for the factors on the form x plus r and r plus s. If expression has more than three factors in the form, look for the factors of them. If an expression have four or more form by, try a grouping strategy like we already did, right? Okay, let's just start with the practice questions, factoring, quadratics, special cases. Hold on. Okay. Let's just practice questions. Okay, let's just start with questions. Create a factorable algebraic expression for each situation. A perfect square trinomial. Okay, you have to make a perfect square trinomial. You have to just write down the algebraic expressions, right? A perfect square trinomial. Perfect square. It would be x square minus 2x and plus 4. That would be the perfect square. This is the square of x, this is the square of 2, and here you have, no, it would be 4x here. It would be x square minus 4x plus 4. That is the perfect square, right? Here you have minus 2 times x. So that would be the perfect square of x minus 2 whole square, right? That's how you have to write down different expressions. Okay, the next one is a trinomial of the form ax squared plus bx plus c. Okay, you have to write down the equation like this. Okay, ax squared plus bx plus 6. You can go through the lesson and find the examples like this, then you can write down the equations over here, right? Because it is a very broad question. I have to think and then write down the examples, right? Let's start with question number 4. Determine the value of each symbol. Okay, you have a missing value here. Negative 10a square plus 15a square. Negative 10a square plus a cube plus 15a square. Okay, if you can take common 5, negative 5 and a square. So you're left with 5 times 2 is 10, 2a, and 5 times 3 is 15. You're left with negative 5a square and 2a negative 3, right? You can take common negative 5a square, right? So you're left with 5 times 2 is 10, a plus 5 times 3 is 15. Your a square is already outside, so you're left with 2a minus 3, right? So that means the missing number is, okay, you just have to take common negative 5a. Okay, so when you take common negative 5a, you are left with 5 times 2 is 10, a square, and plus 5 times 3 is 15. It would be 2a square and plus 3 square. Here you have, that means here you have 2a square minus 3a, right? So the missing is 2 and 3. Okay, the next one is 6x squared plus the missing number x minus 10. 6x squared plus the missing x minus 10. This one is missing, right? Then that equals 2x plus missing and x minus 2. Okay, let's just see which one is missing. Okay, you have 6x squared, right? You are given 2x here. So 2 times 3 is x, right? That means this one is 3. Okay, then you have missing here negative 10, right? You're already given negative 2 here. Negative 2 times 5 is 10. Here you have 5. This one is missing. It would be 3. Hold on. 3 times 2 is 6x squared. 2 times 2 is negative 4x. 5 times 3 is 15x. And negative 10. 15 minus 4, it would be 6x squared. 15 minus 4 is 11x minus 10. That means here the missing value is 11. So the question is, it is 6x squared plus 11x minus 10 equals 2x plus 5 and 3x minus 2, right? Okay. The next one is question number 6. Factor each expression. 16x squared minus 25. Okay. This one is the square of 4x, right? And this one is the square of 5. Okay, so when here in explanation you can see, if you have the expression has two terms, check for a difference of square. That is actually the difference of squares. Both the terms are squares. A square minus b square. So you can write them as a minus b and a plus b, right? Okay. The next one is 12x square plus 4x minus 21. Okay, we have to factor 12x squared and 21 times 12 is, hold on, 21 times 12 is 252. So you have to make two factors that when multiplied makes negative 252 and that when added makes 4x, right? So what are the two factors? They are plus 18 and minus 14, right? Let me just multiply. Check 18 times 14 is 252. Yes. And 18 minus plus 18 minus 14 is plus 4. So yes, it is 12x square plus 18x minus 4x minus 21. So from here you can take 6x common. 6 times 2 is 12 and 6 times 3 is 18. From here you can take 14 it is. Negative 7 common, you are left with 2x plus 3. So these are the common factor, that is 2x plus 3, and the next one is 6x minus 7, right? Okay. The next one is question number 7. Factor 10x square plus 3x minus 1. Okay. Ten x square plus 3x minus 1. Okay, you have to factor. Let's just use decomposition. You have to find two factors that when multiplied makes negative 10, because 1 times 10 is 10 and when added makes 3. Okay, 5 times 2 is 10 plus 5 minus 2 is positive 3, and yes, it is 5 and 2. Okay, 10x square plus 5x minus 2x minus 1. You can take 5x common here. You are left with 5 times 2 is 10 and 1. 2 plus x. No, 2x plus 1. 2x plus 1 minus 1 common, and you are left with 2x plus 1. So 2x plus 1 is common and you are left with 5x minus 1, right? So this is the factors. Okay, let's just start with question number 8. Let's just do question number y. Explain why each expression is not factored fully. Let's just start with question number 9. Okay, x4 minus 1. Let me just write down question number 9. X square minus 1 and x square plus 1. Okay, you have to explain why it cannot be fully factored, right? You can see this one, x square minus 1. You can write x square minus 1 as x minus 1 and x plus 1, right? That's why it cannot be fully factored, right? Okay, the second one is the same is the case for here, x square minus 9x plus 25. You can factor this term. That's why they are not fully factored, right? From here, you can take 5x plus 2y common. That's why they are not fully factored, right? Okay, let's just start with question number 10. I think you have to make pairs here, then you can factor question number 10. xy minus plus xs minus dx. Okay. xy minus dy plus xs minus ds. Okay, we can take common y here, you are left with x minus d, right? From here you can take s common, you are left with x minus d. So x minus d, x minus d is common and you are left with y plus s, right? Okay, let's just do f part. That is 6x cubed minus 63x square minus 63x minus 13x square. Okay, you can take x common, 6x square minus 63 plus 13x, right? Just rewrite it as 6x square plus 13x minus 63. So 63 times 6 is 378. You have to find two factors that when multiplied makes negative 378, then when added or subtracted makes 13. It would be, what's wrong with the pen? Okay, x 6x square negative 27x plus 14x and minus 63, because 14 times 27 is 378. Yes. Okay, you can take common here from 3x and you are left with 2x minus 3 times 9 is 27 plus 7 common, you are left with 2x minus 9. So the factors are x, 3x plus 7 and 2x minus 9, right? Okay, let's just look at question number 14. Decide whether each polynomial has x plus y as one of its factor. Justify your decision. Okay, basically you have to divide this expression by x plus y. If they completely divide by x plus y, that means that x plus y is the factor of this one, right? Let's start with the first one. xy, let's just factor out and see if we have the factor x plus y. A xy plus 3x square y minus 4xy plus 6x square y. Okay, xy minus 4xy plus 3x square y plus 6x square y. You have to just collect the like terms, right? This is 6 plus 3 is 9x square y and minus 3xy, right? Okay, let's just take common 3xy. You are left with 3x minus 1. No, that means this is not a factor. X plus y is not a factor, right? Okay, just look for the B part. That is x5 minus x cubed y square plus x cube minus xy square. Okay, let's just take x cube common here. You are left with x square minus xy square x cube minus x square minus y square. Okay, from here just take common x square minus y square, right? So it would be x cube minus x and x square minus y square, right? So, okay, you can see here you have x plus y, right? That means x plus y is a factor, right? Okay. Okay, just look at question number 17. Okay, a square with sides that measures x units in drawn is drawn. Then a square with sides that measure y unit is removed. Use the diagram to explain why x square minus y square equals x minus y x plus y. Okay. Okay, if you just look at the large rectangle, it has the area if you remove this portion, right? You are left with, because square has all four sides equal in length, right? So if this one is x, all of them are x. But if you remove this portion, you're left with this one, x minus y, this portion only. You don't have this one, right? So the area of the larger square would be x times x minus y, right? And the square of the then area of the large small one would be y times y minus x, right? So when you calculate the y times x minus y, it would be, hold on, let me, basically, let me make it. When you remove the smaller, it would be like this, right? So this one is x, this one is x minus y. So the area of the larger rectangle would be x minus xy, and the smaller one would be y times x minus y, right? So when you make them combined area, you have to multiply these, right? It would be an x square minus y square equals x minus y and x plus y, right? Okay, we are done with the lesson. You can complete the rest of the questions by yourself later today. So if you need more help with any of the lesson, you can contact any tutor on the Skype. They are available from Monday to Friday.